Hey guys, happy Friday. Technical difficulties means I get to make this video twice, so hopefully it works this time. It's a little disappointing. I always like it when you see me go through it cold, because maybe I had to think a little harder and you got to see me kind of think about it out loud. So I'll probably, I can't really recreate that. So let's see how this goes. Consider this diagram of the quadrilateral ABCD, which is not drawn to scale. Which of the two statements must be true based on the information indicated in the diagram? Okay, so they've told us that we have parallel sides. This is parallel to this is parallel to this, that is a parallelogram. Then they told us this side equals this side. Well, in a parallelogram, opposite sides have to be congruent. So this side equals this side, and this side equals this side, just because it's a parallelogram. And then, because they've told us this one and this one are the same, means this one is also equal to this one, and also equal to this one. So all four sides are also the same, which makes it a rhombus. A rhombus is a parallelogram with all equal sides. All right, complete the proof. The proof uses this theorem. Opposite angles in a parallelogram are congruent. All right, so it's saying this angle is congruent to this angle. Complete the proof that a parallelogram with a right angle is a rectangle. So, okay, so given that we have basically a rectangle, we have a parallelogram with a right angle. That's what we have. Now, pick a statement. When a transversal crosses parallel lines. Well, when a transversal crosses parallel lines, this angle and this angle are called same side interior angles, and they have to add up to 180 degrees. And the reason is same side interior angles add up to 180 degrees. We just know that property. Now, what they did here was they substituted 90 in for A, and then they showed that this has to be 90. And then it says, okay, C has to be equal to A because they're opposite angles in a parallelogram. B has to be equal to D because they're opposite angles in a parallelogram. And now we know that we have a rectangle because the definition of a rectangle is it is a parallelogram that has four right angles. Co wants to prove that there is opposite sides of a quadrilateral are congruent. Then it is a parallelogram. So if I show you that this is congruent to this and this is congruent to this, then it must be a quadrilateral. But we want to restate what he says. So what he's wanting to say is, if this side equals this side and this side equals this side, then we have parallel. So if you just look at the thens, it has to be either this one or this one. Well, actually, no, it has to be this one. Because the thens are, we want to prove it's a parallelogram. This one is the only one that says everything is parallel. So what he's saying is, this is congruent to this, and this is congruent to this, means this is parallel to this, and this is parallel to this. It's clearly A. All right. Bao wants to prove that if a parallelogram has a right angle, then its diagonals are congruent. So I want to prove the diagonals are congruent. So basically what we're going to do is we're probably going to prove that two triangles are equal to each other, and that's what they're going to tell us. So we're going to use angle, side, angle, side, angle, side, angle, side, angle, or side, angle, side to prove different triangles are congruent. So we want to know which ones we're going to do. So ABC is this triangle right here. Is congruent to CDA. CDA is over here. So ABC and CDA don't give me both diagonals. It only gives me this one. That can't be the right one. So we're already out on A and B. A and B don't make any sense. So then CDA and BCD. Okay, so CDA gives me that diagonal, and then DCB gives me that diagonal. Now, how am I going to prove that these two triangles, this one and this one, have to be congruent? Well, you know, because it's a parallelogram, that this side equals this side equals itself, and you can show quickly, just like we did in that last problem, that these angles are equal. So we're going to do side, angle, side. All right, consider the diagram, not drawn to scale. Which of the two statements must be true based on the information provided? Well, basically, they've told us this side equals this side equals this side. So what must be true? Does AC have to equal BD? Just based on what's drawn. And we have to choose two answers. Okay, so we're picking two things that must be true. Let's see. AC must equal BD. Triangle ABC must be congruent to triangle CDA. Now that's what we have for certain, because this triangle and this triangle have one set of equal sides, two set of equal sides, and then this side equals itself. So ABC and CDA have to be congruent. AB has to be congruent to DC. That's literally marked. That has to be true. Said you pick two. All right. We're going to complete the proof. This proof uses opposite sides. So we're going through a proof. We're going to prove that AB and CD bisect each other. That AB, CD bisect each other. So that this cuts this. They both cut each other in half. So we start off by saying they're parallel. That's given. It's a parallelogram. 1 has to equal 3. 1 has to equal 3 because they're alternate interior angles. 2 has to equal 4 because they're alternate interior angles. AB has to be congruent to CD, opposite sides of a parallelogram. So now we've talked about this triangle up here and this triangle down here. This angle equals this angle. This angle equals this angle. This side equals this side. We clearly have angle, side, angle. So I don't even know what triangle we're talking about necessarily yet, but it's angle, side, angle. So we just showed that ABE has to be congruent to CDE. Now, that would mean, okay, so this would have to equal this. They are in different triangles, corresponding parts. We don't know that this angle equals this one. We know this angle equals this one, and we know this angle equals this one. So this is a corresponding part to this. So AE has to equal CE, and BE has to equal DE because of corresponding parts. Vera wants to prove that any rectangle is also a parallelogram. Let's restate what she wants to do. So she wants to start out that it's a rectangle. Well, rectangles have all right angles. So in quadrilateral, they're defining a parallelogram. That's not the one. If quadrilateral ABCD, if the measure of angle A, okay, there's all the angles are equal. That's 90 degrees. That's a quadrilateral. Now, a parallelogram has parallel sides. So AB is parallel to BC and AD is parallel to BC. That's what she wants to prove, to show that it's a parallelogram. Now, here's the thing. This one also is very similar. If you can prove that AB is congruent to DC and you can prove that AD is congruent to BC, you can then say that's one of the properties of a parallelogram, but it's not actually where you want to end up. The definition of parallelogram is not about congruency, it's about parallel. All right, I hope it helps seeing me go through that one. I know that one's really hard, and we're going to move on a lot mostly from proofs from here on out.